Okay, this is lesson 2.1 on one-step equations. I am feeling a little bit under the weather, so bear with my deep voice. The lesson target is to solve one-step equations with one variable, and I kind of make the assumption that you have done these types of problems before, but I do want to go over a couple of tricky ones that most people struggle with. And here we go. Now, you've noticed in the other lessons, in previous lessons, that we've talked about some properties in math. They're kind of complicated, they're kind of common sense. Your book does the same thing for this lesson. The addition and subtraction properties of equality on page 81, and the multiplication and division properties of equality on page 83. You can read through those if you'd like, but pretty much it's the same old rule, and I call it this. It's the what you do rule. What you do on one side of an equation, you always do on the other side. If you add on one side, then you're going to add on the other side. If you subtract, or if you multiply or divide on one side of an equation, then you'll do the same thing to the other side. So, you don't have to take Cornell notes. Just write down problem 1 in your notes, and it says x plus 4 equals 13. To solve this equation, you're solving for x, trying to get that all by itself. You're going to get rid of the plus 4. Now, I'm going to talk about this in a later lesson, but when you solve equations, you're going to use the order of operations and go backwards. So you're going to start at the bottom and look for any addition or subtraction and do the opposite. So in this problem, when it says x plus 4, you want to get rid of the plus 4 by doing the opposite, which is subtract 4. And what you do on one side, you do on the other side. So this equation, when you add plus 4 and minus 4, you get 0. X equals 13 minus 4 is 9. Now, like I said, I assume that some of you have seen this before, and for many of you, this will be super easy. But notice that my equations work down the page, and that I show each step, and that I work neatly through the problem and circle my answer. Okay, problem 2 says negative 28 equals x minus 4. You are trying to solve for x. And there's a subtraction, so you do the opposite, which is add, and you add 4. And what you do to one side, you do to the other side. Minus 4 and plus 4 are opposites. They cancel each other out. You're left with x. Negative 28 plus 4, as we talked about with adding integers, is negative 24. Those are one of the most basic types of one-step equations, but there are some problems that get a little tricky. For example, and this is still example 2, many people will look at this problem, negative 28 plus r equals negative 4. They'll see the plus here, and they'll decide to subtract 28 from both sides. And the problem is that negative 28 and negative 28 don't cancel each other out, so that's not going to solve your equation. So you just have to be careful to make sure that you understand completely what you're doing when you're adding or subtracting to both sides. In this problem, negative 28, the way you get rid of it is to add 28. And you do that to both sides because what you do on one side, you do on the other side. Those two cancel. R equals negative 4 plus 28 is positive 24. Okay, so those are basic examples of addition and subtraction. Problem 3 is an example of multiplication. The 3 and the n are being multiplied. And so to get rid of a multiplication or do the opposite of multiplication, you would divide both sides by 3. Because this 3 and this 3 cancel, you get n. What you do to one side, you do to the other side. 3.9 divided by 3 is 1.3. In problem 4, the letter P is being divided by 12. The opposite of division is multiplication. So you multiply both sides by 12. Oftentimes students will see this problem and think, oh, 12, yeah, 12, let's see, 36 divided by 12 is, just make sure that you're always trying to get rid of the numbers or get the variable by itself by doing the opposite operation. So this 12 being multiplied cancels out this 12, which is dividing, and then you multiply 36 times 12, and you get 432. So P equals 432. Now the last problem is slightly different in that the 3/5 next to the T is being multiplied. And the what you do rule says if you're multiplying, then you do the opposite and you divide. But when you have a fraction, dividing fractions gets really weird. So this is kind of the exception to the rule. And that is when you have a fraction involved, you're going to use the reciprocal rule. And the reciprocal rule just means this. If I take a number like 2/3 and I multiply it by its reciprocal, that means to flip it over. 2/3 and 3/2 are reciprocals. Anytime you multiply a number by its reciprocal, you always get 1. 2 times 3 on the top equals 6, and 3 times 2 on the bottom equals 6. 6 divided by 6 is 1. That works for every single number. So in this problem, to get the T all by itself, I'm going to multiply the left-hand side by the reciprocal of 3/5, which is 5/3. And what you do to one side, you do to the other side. 5/3 times 3/5 gives you 1 T. On the right-hand side, 12 times 5/3, you make the 12 a fraction by writing it over 1. 12 times 5 is 60. 1 times 3 on the bottom is 3. And 60 divided by 3 is 20, so T equals 20. Now that was really quick. I went through 5 problems rapidly. Again, I assumed that you knew this. If you have questions on this, be sure to bring those to class with you tomorrow, and we'll work together on some problems.